Hi all 3 history students. Again, I apologise for the poor sound quality, but I'm recording this at home. But hopefully you'll be able to hear what I'm saying. So we're going to look at the difference between object literals and constructor functions and all of that object-oriented JavaScript notation. So if you remember back to the good old days of 103, when Mama sang you to sleep and now you're stressed out, we remember when we talked about classes and objects, we had that analogy of building a house where you first had to plan a house. So you got an architect to plan your house and stuff. So that was considered a plan because it describes your objects. And then you can create a house from that plan, and each house that you create is the same. And these are all kind of considered objects. Well, in JavaScript object notation, we think of each individual house as an object literal. Okay, so each individual house is called an object literal. And because JavaScript is such a crappy language, you can actually create an object literal without having a plan or a class which describes it first. You can basically just create object literals on the fly. So basically you can just create your houses on the fly. And of course that can lead to disaster if you don't plan it properly, just like a normal house. So you have to be really careful when you're creating your object literals. Okay, so each kind of object or house that you create is considered an object literal in JavaScript notation. And if you were to create a plan of your object, then instead of being a class, this is called well, basically it's a constructor function. Okay, so the constructor function is what we use to create a plan of our object literals when we create them later. Alright, so that's kind of the distinction between a constructor function and object literal. So a constructor function, you can think of it like a class in normal programming languages, and an object literal are like objects in a normal programming languages. But remember, in JavaScript notation, you can create an object literal without first having a constructor function. You can just create them on the fly. Okay, so that's what we're going to do in our first one, in our first exercise. Now, it will make a lot more sense to you if you actually type the code as we go. So on Facebook, I've posted the OOJS Example template. You can download that, unzip it, and then open that up in your favorite HTML editor, and you can follow along as I go. So I think it's much better if you actually type the examples as we go. You can play around with things by pausing the recording and seeing what happens, and it'll make much more sense to you, and you'll actually learn a lot more than just watching the recording. So I really do recommend you type stuff as we go, because as you know, if you're typing stuff, you're practicing that, and it'll hopefully keep in your memory. Alright, so yeah, download that, open up the file. So there's an index.html file. All it's got is 3 buttons that will allow us to execute an object literal function, a constructor function, or a private properties function. So if you have a look on it, click on that button to do the object literal example, click on that button to do the constructor function example, click on this one to do the private properties example. So that's all set up, it's all ready to go. All we need to do is write the code for those functions. So there's a JavaScript here. So we're going to write our first example of creating an object literal in this function here. Okay, so all you do is you just create a new variable for your first object literal. So we're going to use a student as an example, so let's call this student1. So OBJ, so student1 is the name of the object literal, equals. A lot of people put the curly brace here. Personally, I don't like that. I like it when it's all lined up, so I like putting it here, but that's entirely up to you. Now, all you need to do is to just create some what are called properties, or you can think of them as fields if you come from 258, same sort of thing. So you can just go name, then a colon, and then at this stage we'll just make it equal to an empty string. Oops, not a semicolon, it's a comma there, so you have to just watch out for the notation. So that'll create a new property for you called name, and initially it will be set to an empty string. You can do the same thing for the ID, so ID set to 0, comma, and phone is an empty string, and email is an empty string as well. Now you don't put a comma after on the very last property, so you have to remember that. I'm not sure if it gives us an error. We can test it and see what happens. But you do need a semicolon, whoops, not there, at the end of your object literal creation code. So you need a semicolon here because that ends our creation of that student. So we've just created a new object literal, or an object, but we haven't had to create a class or a description of it first. It just creates it on the fly. Okay, so that's one object literal, and now we can actually put some values into that person. Well, let's just see what happens if we were to output, say, the ID. So we can go, so we're going to put everything into the div. So I'll do a document.getElement by ID, and the div is called results. Dot inner HTML equals, so when you're student 1, so remember, use the dot notation, name of the object literal, dot, and then the name of the field. So using brackets, it's really nice because it pops up with the properties in there. So let's just pop up ID, and hopefully that will display 0, right, because ID is set to 0. If we displayed one of the other things, it won't show anything because they're an empty string. So let's save that. Okay, so hopefully you've typed that up yourself, so you're ready to run it. So let's go back to here, reload that page, click object literal, and we can see that the ID 0 comes up, so it has been created. Okay, so let's comment that bit out, and what we can do now is put in values for all of the other things. We can go student1.name equals Brad Weber. He's an amazing player, by the way. So student1.name, student1.id. So just pretty similar to using C# objects or processing objects. Let's make it ID number 100. Student1.phone equals 838 5555. And then student1.email is equal to brady@chiefs.com. Okay, so that's how we can now put things into our student object literal. Okay, and again, we could display information about that person by doing this. So we could get the name, so here student1.name plus maybe have a space there, and let's all display their email address. So student1, actually I might just drop down to the next line so we stay on the screen. Student1.email. Okay, so get the name and email, join them together. That's missing a plus there. Okay. Alright, so hopefully you've typed that in. Alright, so let's see what happens when we execute that. So refresh the page, click object literal, and there we go, Brad Weber, and then Brady@chiefs.com. Excellent. So that's the gist of being able to put things into your object literal. Now, what would happen if we actually just mistakenly put a capital N instead of a lowercase n? Wonder what happens there. So let's save that. Let's execute that code, and oh, it's not there anymore. So what happens is that it actually creates a new property called capital N name rather than lowercase n name. So it's actually got two fields now, one called name with lowercase and one called name with uppercase n. Okay, so you can actually create new properties on the fly for your object literal, but it only applies to student 1. It doesn't apply to any other object literals. So you can see that by doing that, if I put in a capital N here, and you can see in the pop-up there's a capital N with name and a capital and a lowercase n for name. Okay, so if I run that, it will actually give us the name this time. So there you go, Brad Weber. Okay, so you have to be, and you can see that even though I've got use strict here, it doesn't work. It just automatically creates a new one for you. So when you're doing JavaScript object notation or OO JavaScript, you have to be really sure about what you're typing in, because you just mistakenly type a name in wrong, it's going to create a new one for you. Alright, so just watch out for that, which is really annoying. Okay, so that's the basics of creating a object literal. Okay, now if I want to create another object literal to store another student's information, then I have to create everything again because there is no class or constructor function for this. So I have to go var student2 equals, and this time when we create it, we'll give it some values when we add the properties in. So we're going to go name, right, Damien McKenzie, is it Damien? I think it is. Oh well. Damien McKenzie, ID 101. Oh, it's not a semicolon, it's a comma. You have to get used to that, unfortunately. Phone 8384444, and email demo@chiefswhoops.com. Again, no comma at the end. Actually, we should see what happens if I put a comma there, see if it gives us an error. Okay, and if I want to display that person's information, we can do all of this again. I'll just do a plus equals here, and actually I might join a BR on here so that the next thing is underneath the previous results, just so we can see the previous results as we go. Okay, plus BR. Okay, and that should be student 2 this time, and this is student 2. So we should see Damien's name and email address. Now we'll see if that comma there actually gives us an error when we try and execute it. So remember, when you're testing, keep your Firebase console open. Oh no, it worked. So there you go. You can have a comma at the end of it, or you cannot have a comma at the end of it. Don't you just love JavaScript? Yay. Okay. Yeah, Damien with an A just sounds wrong, but never mind. Okay, so that's how we create object literals. You just create them on the fly, and the object literals could be different, right? I could add an extra field in here. What do I want to put? Position. Here's a fallback. Okay, and I can output, instead of his email, I can output position here, and we will see that in the Java, in the browser window. So let's run that. So yep, you can see it's got fallback there. But if I go back to student 1 and put position here, then if I save that and execute that, you'll see it's undefined because that object doesn't have a position property, but the second one does. Okay, so basically object literals are okay. It lets you group things together, but it's not quite as nice because you can get into problems because you get some objects with some properties in it and different objects with different properties in it. Okay. Alright, so let's have a look at how we can now extend an object literal to have a function which might, say, display all the information about this person. So in student 2, let's create a function here. So let's just go put the name of the function that you want first. So let's call this display info. Okay. Oh, not. Yes, you got to do that. Then you got to type function equals. No, it's not equals. Okay. Just function. And then again, most people put the curly bracket here and do that. I'm a rebel and I like to do that just because I'm used to that. So it's up to you how you want to do that. So what I want to do is do this bit. And I just want to output all of his information. Okay, so I want to go name. Now, to use your properties inside a function, inside your object literal, you can't just put, well, we'll try it. If I go name, let's see if the name will show up. Okay, so we'll get rid of this bit. And all we need to go is student2 dot display info. So that calls the display info function inside your student2 object, and that should output Damien's name. So let's see what happens. And you'll see that nothing appears, alright, because we can't access these fields like by just putting that the name of that field there. So what you actually have to go is go this dot name. So that means this is the current object. So for this current object, access the name inside this object. So when you have a function inside your object literal, you have to go this dot name, okay, or this dot whatever. So just please be aware of that. So let's go comma and then join ID number. So this dot ID. So hopefully you're typing this into your code as you go. So maybe pause it and then type stuff in. So why don't you pause it, finish the rest off, and then come back. This dot ID plus this dot phone plus comma plus this dot email. And I won't worry about the position. Okay, so this is how we can create a function inside our object literal, and it will just execute that code. Alright, so hopefully this time we will see all of Damien's information. So let's save that, go back to the browser, click object literal, and there we go, we can see all his information all in one go. So that's really nice, because it means that if I ever want to get the information about the student, I don't have to type this in every time. I can just call this function and it does the work for me. Right, so just remember, inside an object literal, you have to use the this keyword when you're accessing various parts of it. Okay, so remember, if you mistype something, you can create new properties on the fly, unless you actually wanted to do that. So you just need to be aware of that. So just make sure you do type all the names and stuff in correctly. Okay, so another thing we can do is have an object literal inside another object literal. So you can see that for the name, there's actually two parts, a first name and a last name. So we can actually use an object literal for the name. So that means we can break it up into two parts, but they're still stored inside an object literal. So let's create a new object literal object here. So we'll copy this one, and then we'll just change it. So copy that one. So copy that in your code, and we'll call this student3. Let's choose a different person. James Lowe. 102, 1111, jamie@chiefs.com, and we're going to take out the position for this person. Oh, delete. Okay, so we want to use an object literal for the name. Okay, so we're going to get, or maybe I'll just comment that line out. So this is how we do it. So we go name, then our colon, and then we just start off into our object literal. Alright, so we just go first name, James, comma, last name, Lowe. Okay, so that's how you create an object literal, and then over here you need a comma, right? Because it's still treated as one property. Okay. So how do we, if I go do this, and go this.name, let's see what it displays. So let's execute that, refresh that, and we didn't output James Lowe, did we? So we need to do that. So we need to go student3 dot display info. Okay, save that. Now let's run that again. And so you can see that it's got object because it's not accessing the first name and last name, because we're trying to access the name field, which is an object, so that's why we get object there. So we're not getting the name correctly. And actually in here we should add a BR, just so that drops down to the next line. And I should add that into the previous one, just to make it look good. Okay, so we can't access the name directly of that because the name is an object literal and it's got two things inside it. So we have to go this.name dot first name. So that gives us access to the first name plus a comma plus this dot name dot last name. And let's drop that down to the next line. Okay, so we're going to access the first name and last name. So this dot access the object literal called name dot access the property inside that called first name. So hopefully that kind of makes sense to you. So let's execute that, and hopefully we will see James Lowe appear. And there we go, we've got James Lowe appear in there. Oops, wrong thing. Okay, so that's how you can have an object literal inside another object literal. Now you can see that we've created 4 object literals, but what if we needed to create 100 student object literals, because I want us to 100 students? Well, we're not going to create them the object literal way one by one, because that's going to be a huge amount of work. Okay, so what we're going to do is we're going to create a constructor function. Okay, so we're on to constructor functions now. So essentially constructor function is kind of like a class in C# or processing. It essentially does the same kind of thing. Okay, so we're going to move down to the constructor function example, and we're going to create a constructor function just above it. Okay, so to create a constructor function, you just go function, because it's just a function basically, but we can use it to construct object literals. So function, let's call it student, and bracket bracket, and then we create put our curly braces in for our constructor function. Okay, so first thing is to create our properties. So we can go this.name equals, and then we'll just put our person's name in here. So Michael Leach. This.id is equal to 104. This.phone is equal to 838. 999. So notice when you're creating a constructor function, because it's an actual function, not inside an object literal, instead of commas, this time we use semicolons. Gee, wouldn't it be great if people just were consistent? But no. Okay, so we need to use semicolons inside a constructor function, so just be aware of that. Email equals Leachy at chiefs.com, and you do need a semicolon at the end of every single line. Okay. And we can also create our own function inside our student object, like the display info that we had before. So we're going to go this.getInfo, and this time rather than displaying the information directly into a div, we're going to write a function that returns back the information, and then in our JavaScript function here, which is called by our button, we can get the info returned back from our student object and put it into the div manually. Because that way, you might not want to put it into div, you might want to put it somewhere else. So get info equals a function, bracket bracket, and again you need to put your curly braces. So I like to put them along the same line because it's just me, but it's up to you how you want to do that. And then in here we can just go return back and then join up all our information. So let's put the ID first this time. So again, you have to go this.id to access the fields. Okay, so this.id plus a comma plus this.name. So remember, it's just the normal name property this time. It's not an object literal inside there. We'll look at that later on. So just this.name plus comma, space there, plus this.phone plus a comma plus this.email. And then let's put a BR on the end of that. Alright, so it's got 1, 2, 3, 4 properties. Initially, every single student object we create will have the same name, and it has a getInfo function that returns back all the information about that particular student. So that's a constructor function. So you can think of it like a constructor inside a class if you've done Comp 258 or Comp 104. So basically it's a constructor for a class, but there's no other class stuff around it basically, because any other functions are inside the actual constructor function. So that's how you basically create a constructor function. Okay? So again, maybe pause the recording, make sure you've typed all that in, so we can see if it works. Okay, so now we want to create a new student object from this. So we just go var student, what are we up to? Student 4 equals new. We're creating a new object literal from our constructor function. So just like creating a new object from a class in C# or processing. So var student 4 equals new student. Because these brackets are empty, we leave these brackets empty here. Okay. Then we can do the document.getElementById that we did before. Do a plus equals that we can see what's in it. And we can go student4.getInfo. So it joins the string returned back from getInfo and puts it into the inner HTML. So let's run that, and hopefully we will see student 4's information appear. There we go. So you got all that information about Michael Leach appearing. Okay. And if I were to create another student, var student 5 equals new student, and then I could just do this code again, but this time we want to display student 5's information. Oops, spelled that wrong. Okay, let's run that. And now we have our two objects, student 4 and student 5. But it's not much good having our constructor function always assigning them to those particular values. I mean, we could do this, student5.name equals Sam Kane. Is it Kane like that or Kane like that? I think it's that. Alright, and if we execute that now, hopefully student 5's name has been changed to Sam Kane. So let's try that. Yep, so you can see that Sam Kane has been changed. Okay, so we could do that, but it's a little bit tedious having to do that. So another thing we can do is we can actually pass values to the constructor function just like you can do with a constructor inside a class. Okay, so if we go back to our student constructor function, we can just create parameter variables for each thing we need to pass in. So remember, you just put the name of the parameter variable, you don't have to go var or int or string or anything like that. So just go name, comma, ID, comma, email. Oops, phone, comma, email. Okay. Actually, let me comment that out and just create a new one so we have the original one there. Okay, so let's do that again. So we want name, comma, ID, phone, and email. So we can pass in the information, and then we can go this.name is equal to the name over here. How do we differentiate between the field and the parameter variable? Well, this.name is the field. Just the name of your parameter variable means it's parameter variable. Okay, if you don't go this, it means you're looking for one of these variables. So this.id equals ID, or just make them completely different names somehow. This.phone is equal to phone. This.email is equal to email. Okay, so that means when we create the constructor function, we can now pass in values to that. Alright, makes it much easier to do. So now, when we create student 4, we can pass in the name, so Michael Leach. Comma, 104 was the ID number, comma, phone, 838-9999, comma, and then let's drop down to the next line. Leachy at chiefs.com. Okay, and then we can create Sam Kane as well. So Sam Kane, comma 105, oops, comma 105, comma 838. Sammy@chiefs.com. Alright, and so now when we display their information, that will display the information that we pass in to the constructor function. So let's run that again. So we've got Michael Leach, and there we have Sam Kane. So by passing in values, it makes it much easier for us to create new students. It's much more compact, okay? And we can do that stuff. Alright, so that's kind of the basics of using a constructor function. Remember, whenever you're using one of your fields, you have to go this dot. If I just put ID here, it'll probably give us undefined or something, so let's try that. That's interesting. I would have thought it would have. Oh no, it's using ID up here. So that will so when it uses ID, it's using this variable here, not that one there. So that one will actually work. There was one I was thinking of where. Oh, that's right. When we did the. Yes, I'll show you in a minute when we do the name. So, just like before, we want to break up the name into two parts. So have a object literal for that. But again, you could create a constructor function for the name object literal. Okay, so we could do this. Function, name, and we could pass in the first name, and pass in the last name. Alright, and so we can just go this dot first name is equal to first name, and this dot surname, no, last name, is equal to last name. Okay, so hopefully you've been pausing and creating the code as you go. So create the name constructor function. Alright, now with our student, we want to change what's passed in because the name is passed in with the first name and surname and last name together. You could be tricky and try and break them up, but let's just make it easy and pass them in separately. So we'll go first name, comma, last name. Alright, so when we create the name field for student, we actually want to create a new name object literal. So we're going to go new, name, and then pass in the first name and pass in the last name. Okay, so it creates a new name object literal using first name and last name and makes name equal to that object literal. Okay. So if I just, when we return the information, if I just go this.name, let's see what happens. Now I do need to fix this up so that we pass the surname, the first name and last name in separately. So I need to break those up. Right, so Sam, Sam, comma, and then last name, comma, and then ID and so on. So let's execute that and see what that looks like. Alright, so for the name, you see we've got object because we're outputting the name and not the first name and surname, what's in there. Okay, so what we could do is try and go this.name dot first name. Okay, let's see what that does. Oh, cool. So it does give us the first name, right? And we could plus this.name.surname. You could do that as well. Or, alternatively, we could create a function here like we did for getInfo for the student, right? So we could go this.getName equals function. Okay, and it's just going to return back first name. So this dot first name plus the space and then plus this dot last name. Okay, so if I call the getName function of our name object literal, it will give me back that information. So we could do them separately, this.name.firstname plus a comma plus this.name.last name, but this makes it easier for us, right? If we have a function that does it. So we can go this.name.getName, bracket bracket, okay, and that will execute that function. That string is returned back to here and joined into here. So now we should see their names appear. Oh, so we've got undefined, undefined. So I must have done something wrong. Let's have a look. This dot last name. Oops, that's the equals, the minus. I'm surprised that didn't give me an error. JavaScript, lovely language. Okay, so now we've got the full names appearing. Okay, so that's how we can have constructor functions and use them inside another constructor function. Okay, I think that's all I need to talk about for constructor functions. Just let me check all the different things. Alright, and you can see that with constructor functions it makes it very easy to create lots and lots of objects for that. Alright, now the other thing is, you know how previously you could add a new field to a constructor object literal, like position fullback, but it only gets added to that particular object? The same thing applies when you create an object literal from a constructor function, but if you want to give it for all of your object literals later on that you create afterwards, then you can add it through what's called the prototype. So let me comment the getName function out so that none of our objects that we create have getName functions. If I were to execute that, we'll get some sort of error. So yes, it says it cannot find the getName function. Alright, so we get an error there. Okay, so I've created these constructor functions. I've created these objects. I want to create a new function inside all of those on the fly. So we can do that by using the prototype method. So we can go student, because it's the name of the constructor function, dot prototype. Dot, and then the name of, so you can add properties to all of your, so we'll look at the properties in a minute. So So get name equals function, and let me just grab this. Paste that. Alright, so this will add the get name function to all of the objects that have been created using the student constructor function. So now when I execute that, we should see the name correctly, right? Because we've added the get name function to all of our object literals that are based on that. No, okay. Why did that not work? Get name. It's not in student, is it? Because the get name function should be inside the name constructor object, so that should be name. So we're adding it to the name, not the student. Okay, so that's added the get name function to the name function constructor function, and you could do the same thing for student if you want to, and we'll look at that in a minute. So let's run that, and hopefully this time it'll work. And there you go, we can now see that the get name function has been added to the name object literal inside each student. So if I wanted to add, say, a position to each object, we could do that. I haven't tried it before, but we'll try it, shall we? So we're going to go student.prototype, lowercase, dot, let's say we want to store someone's position. I don't think it's already in the student, is it? No. Dot position. I think it's just equals. I'll make an empty string. Maybe we should put something in it. Fullback. And we should be able to go student5 dot position, and you can see yes, position is actually there now. Okay, I love brackets, it's really cool. I don't think Aptana would do that. So you can see that fullback has been added to student5. Okay, so that's how you can add a new field to all of your object literals created from your constructor function. Okay. Alright, so that's how we use constructor functions to create object literals from them, and it does make things much easier. Okay, so the next thing we want to look at is the difference between private and public properties. Okay, so again, let me grab these constructor functions, and I'll comment all these out because we're going to move them down, use them down the bottom. Okay. Okay, so let's put this back in because we're not doing the prototype bit anymore. That's in the other button. Alright, so at the moment, if you go this.name to create any of your fields, that makes all any of your properties, that makes all of the properties public to everything, all of the code outside your object literal. So if I create a new student, var student6 equals new student, I'll just put Sam Kane back. Sam Kane 6 838. Alright, so we can do that, and if we were to do our document get element by ID again, so remember you should be typing this code as you go, pausing and typing stuff in, because that will hopefully make it easier for you to understand. So I'll just go name dot get name. No, let's do something else. Dot email. Okay, so we should be able to get direct access to the email property through this function here. Yep, you can see his email appears. So basically we have full access to all of these properties. But obviously that's not a good thing, because you let everything have access to those and you can change them whenever you want, which is not a very good thing. So generally we try and make all properties private and then give access to the properties using functions as required. So how do we make things private? Well, to make them private, we go do this. VAR, so we're creating a new, so remember when you go VAR, you're creating a new variable locally inside whatever it is that you're creating, where you're creating it. So VAR, and generally we use the underscore notation just to differentiate a property variable from a normal variable. Okay. So VAR ID, VAR phone, VAR email, and actually for getInfo we do want that to be public, right? Because we need to be able to call that function from outside of the object. So we do go this dot getInfo for that one. Okay, so if I were to run that and try and display the email, it might give us an error this time. No, it just says undefined because it can't find it. Okay, so it doesn't give us an error. But it's private, so we can't get access to it, okay, by doing that. But we can use our variables inside our getInfo function that returns back all that information. Okay. So when you're using VARs over here, then if you go this.id, it's looking for a global ID variable, but our private field is the underscore ID, so it's not going to find that. Actually, let's just run that and see what that gives us. Student6 dot getInfo. Let's see what that actually produces. Okay, so just so name is undefined, so it can't find the name, so you can't go this dot name, it can't find it basically. Okay, so when you're using private fields, to use these local variables, you just put the name of it. So you just go underscore VAR, underscore ID. This will be underscore name dot get name. So it calls the get name function from the name private property. This will be underscore phone, and this will be underscore email. And even in your name constructor function, we should make these private. So VAR first name, VAR underscore last name. Get name we leave as public, and then over here we just go underscore first name is that, plus underscore last name. So those are all private, right? We can only get access to the information by using the public functions, which is what we want, because it means it's the safest way of storing the information inside your object that you create from your constructor function. So that's basically the general tenet of object-oriented programming. We make all of our properties private, and then we provide functions to get access to those particular things. Okay, so now if we go getInfo, that should work because it's using all the private properties. So let's try that. So there you go, there's Sam Kane, and his information is being displayed. Okay. So that's the difference between private fields and public ones, is basically you want to use VAR when you're creating your fields rather than this. So this dot means it's a public property, VAR, and then the name means it's a private property. Okay. But what if I wanted to allow me to change the email for Sam Kane later on? Well, I can't get access to email directly, alright, so I can't go, move that down, I can't go student6 dot email equals Sam Kane at chiefs.com. If I try and execute that, that should give us an error. So remember what happens, it creates a new one for you on the fly. So that's just created a new property called email for me inside that. So it's really annoying, right? So because there is no public property called email, there's a private one, but it's just created a new one for you. So that's not ideal because it should really give us an error when we do that. But JavaScript is such an awesome language that just does things for us. Makes it easier for us, you know. Yeah, hopefully you can tell my sarcasm there. Okay, so that doesn't work. We need a way of being able to access our private email field and update it. So to do that, we have to create a function. So this dot set email, alright, equals function, and for this function, I need to be able to pass it something. So I need to be able to pass it the new email, right? So we put a variable in here so that a new email is passed in, and then I can go, the private property is equal to the new email parameter variable. So that allows us to set that. So let's try and, so that's called like a setter function that allows us to set the values of your private fields. So now I should be able to go student6 dot set email and then give it a new value. So Sam Kane at chiefs.com. And then when we do get info, the private field underscore email has been changed through our setter function here. Alright, hopefully I've done it correctly and it'll work. And there we go, yep, Sam Kane at chiefs.com. Okay, so that actually allows us to do that. Now, what if I wanted to just display a person's email? Well, we can't do it through the setter function because that only sets that value. I don't want to use the get info function because that gives me everything. If I just want to get one particular property, I need to create a getter function that allows me to get the information. So in our student constructor function, we want to go this dot get email equals function. We don't have to pass anything into this function because all information is already inside your object, and we can just go underscore, no, we just want to go return underscore email, so that returns the email back. Okay. So this time I can go get email bracket bracket, and it should now display just the email for Sam Kane after it's been changed. So let's execute that. So there we go, we just get Sam Kane at chiefs.com. So that's an example of creating a setter function inside your constructor function that allows you to set the value of one of your private properties, and this is an example of a getter function that allows you to get the value of one of your private properties if you don't want to use the function that returns everything back. So it just kind of depends on what you need. Sometimes you might want to have setters and getters for things, sometimes you don't want any setters and getters for things because you don't want to create them in the constructor function. So it just depends. Alright, so that's kind of the basics of using constructor functions and the difference between private and public fields. So hopefully that's all made kind of sense to you. Again, I really do recommend that you write all this code down and maybe write comments for all of those to make sure you fully understand what's going on, because that will really help you as well. And I will post all of this code that I've just done here, and I'll post that on Facebook for you. Alright, so hopefully that's helped out. So I'll see you next week, and good luck studying for the test. Feel free to come and see me if there's anything you're not quite sure about. Although I'm just a student, so I probably know just as much as what you do. Okay, see you later, bye.